Hi everyone. Let's take a look at number 9 on page 106. Find the rate of change of each function at the given value of t. Leave your answers as rational numbers or in terms of roots and the number pi. Part B, s of t equals to, open bracket, t minus pi divided by t minus 6 pi, close bracket, to the power of 1 over 3, evaluated at t equal to 2 pi. Step number 1, find the derivative. So in this case, when we're looking for s prime of t, we're applying the chain rule. And again, just in case you forgot about the chain rule, the chain rule states that if there's a function h, which is in terms of f of g, the derivative h prime equals to f prime of g times the derivative of g. So in this case, you're going to bring 1 over 3 to the front. You're going to copy t minus pi divided by t minus 6 pi to the power of 1 over 3 minus 1, which is negative 2 over 3 times the internal derivative. So now we're going to apply the quotient rule. Again, there's 6 steps when it comes to the quotient rule. The first step is to square the denominator. So t minus 6 pi quantity square. The second step is to copy the bottom to the top. So t minus 6 pi in brackets times the derivative of the top. When you take the derivative of t minus pi, that's going to be 1. Don't forget, minus, unlike the product rule, you're adding in order doesn't matter, but for the quotient rule, order matters. And remember, this is minus. Minus, you copy the top, t minus pi, times, and this is the final step, step number 6, by the derivative of the denominator, which is t minus 6 pi. And when you differentiate that, that equals to 1. Now, your goal is to plug in time to be 2 pi or t to be 2 pi. So again, there's no need to simplify this. You can go straight to substitution. So 1 over 3 times 2 pi minus pi divided by pi minus 6 pi in brackets to the power of negative 2 over 3. And in the second bracket, again, I'm going to start with the denominator, 2 pi minus 6 pi in brackets square. Here at the top, it's going to be 2 pi minus 6 pi minus 2 pi minus pi. Now at this point, you could take your calculator, turn it on, press clear, and work it out. But I'm going to demonstrate a little bit of mental math. So s prime of 2 pi equals to 1 over 3. If you take 2 pi minus pi, that's going to be pi, divided by pi minus 6 pi, that's negative 5 pi, which I'll put in brackets, to the power of negative 2 over 3. So notice right now I can cross out pi divided by pi, which equals to 1. And if I keep going, again, I'm starting with the denominator. 2 pi minus 6 pi is going to be 4 pi, or I should say negative 4 pi, in brackets, square. If I look at the top, 2 pi minus 6 pi is going to be negative 4 pi. 2 pi minus pi is pi, so you're subtracting pi. Now, let's keep going. This equals to 1 over 3. And as I'm looking back at my notes, I'm thinking I made a mechanical mistake here. So you know what? When you keep this in the recordings, you can see what happens when I do something live and I'm mentally checking. So this should be 2 pi, because if you go back to the first step here, I'm plugging in 2 pi for t. So this should be 2 pi, by the way. And if you're watching this and you're kind of doing this at the same time, you can update it accordingly. Let's go back and delete this. And 2 pi minus 6 pi is negative 4 pi. There we go. So now look what happens, right? I don't want the negative 2 over 3. I can go from negative 2 over 3 to positive 2 over 3 by taking the reciprocal. And the reciprocal of 1 divided by negative 4 is negative 4 divided by 1. And in this last bracket, that's going to be negative 5 pi divided by 16 pi squared. Now, when I work it out, s prime of 2 pi equals to, again, there are a couple ways of doing this. I'm just going to show you one method. So I go back, I can cross out pi divided by pi. I can also go back and copy 1 over 3. When I think about negative 4 to the power of 2 over 3, what I'm thinking is I'm going to square this first. Then I'll take the cube root of that, and I'm going to multiply this by negative 5 divided by 16. Now, let's keep going. We're so close to the end here. S prime of 2 pi equals to, I take negative 5 times 1, that's going to be negative 5, divided by 3 times 16, that's going to be 48. Don't forget the pi. And if I think about this, this is going to be the cube root of 16. Now, this is not the final answer because if you really look at this, you can simplify this a little bit more. Now, just in case you forgot about this, here's a refresher. If you think about the cube root of 16, that is the same as taking a perfect cube times a non-perfect cube. So for example, 8 times 2. And if you really look at it, here comes the final step. Are you ready? The cube root of 2, I'm going to copy as is. But if you look at this, and I'll highlight it for you, this is basically the cube root of 8, which is going to be 2. And 2 divided by 48 is going to be 1 over 24. So the final answer should be negative 5 times the cube root of 2 divided by 24 pi. I hope this makes sense.